Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concepts in our today's mathematics class. So children, are you all ready with your notebooks and pen? Okay, let us start our session today. Today we are going to learn about perimeter and area of plane figures. So by the end of this session, you will learn concept of perimeter, perimeter of plane figures, concept of area, and also area of plane figures. Look at the images shown on your screen, children. Can you identify these figures shown on your screen? Yes, the first one is a triangle. The top one you can see, it is a rectangle, and the below one is a square, and towards your right side we have a circle. And children, do you know what these figures are known as? You are absolutely right. They are called plane figures. So all these figures like triangle, rectangle, square, circle, rhombus, there are many other figures, isn't it children? All these figures are called plane figures. Now children, if you notice at this, that is triangle, rectangle and square, these are called as polygons, and whereas circle is not included in polygons. Now let's see what a polygon is, children. Can you define a polygon now? Polygons are simple closed plane figures bounded by line segments. So that's why circle is not a polygon, children. Got it? Now take a look at this image shown on your screen, children. What do you notice? Yes, it's a beautiful stadium with a running track, isn't it children? Now take a look at Balu here. Now what is he going to do? Oh, you can see he has completed one round. So this distance covered by Balu is called the perimeter of the track. So here Balu, you have noticed, he was running this all the way. He has started from this point, and again after running he has come back to its starting point. So this distance which Balu covered is called the perimeter of the track. Now children, let us see what is the definition of perimeter. The length of the boundary of a closed figure is called its perimeter. Now let us take an image shown on your screen, children. Here A, B, C, D, E, F is a closed figure. We call it as a polygon, isn't it children? Now the perimeter of this closed figure is given by sum of all its sides, that is AB plus BC plus CD plus DE plus EF and plus FA. So perimeter of a closed figure is nothing but the sum of its sides. So children, so perimeter of any polygon is nothing but what, children? Sum of the lengths of its sides. Now let us see the perimeter of a triangle, children. Now take a look at this triangle shown on your screen, ABC. Let the length of the sides of triangle be A, B and C, and even triangle is also a polygon. So perimeter of triangle ABC is sum of its sides. So what are the sides, children, here? A plus B plus C. So we can say that the perimeter of a triangle is sum of the length of its three sides. Now take a look at another polygon, children, that is perimeter of a rectangle. Now consider a rectangle here, ABCD. The length of the rectangle AB here, and BC is the breadth. Similarly, CD is the length and AD is the breadth. So perimeter of rectangle ABCD is equal to AB plus BC plus CD plus DA. So sum of all these four sides, isn't it children? So here in place of AB I can write this as length, in place of BC this is breadth, so plus breadth, plus CD is again length, I am writing it as length, plus DA is again breadth. So we have length plus breadth plus length plus breadth. On adding, what do you get, children? 2 into length and 2 into breadth. Now do you notice anything common here? Yes, 2 is a common factor. On removing 2 as a common factor, you get 2 into length plus breadth. Therefore I can say that perimeter of rectangle is equal to 2 into L plus B units. So this is the formula to find the perimeter of a rectangle, where L is length and B is the breadth. Got it, children? So children, take a look at the figures shown on your screen. I think you know all these figures. They are polygons, isn't it, children? All they have some closed figures with some sides. Now, in all these figures, do you notice anything common? That's right. If you take a look at this triangle, all the three sides of this triangle are equal. Now, if you take this, say, four-sided figure, all the four sides are equal. So, we call it as a square. Now, this is a five-sided figure, a pentagon. All the sides are equal. So, like that, we have hexagon and also octagon. And in these also, their sides are equal. Now, such type of polygons, we generally call it as regular polygons. So, what do you mean by regular polygons, children? Polygons that have all the sides equal and all angles are equal are called regular polygons. So, equilateral triangle is a regular polygon, square is also a regular polygon, and this is a regular pentagon, regular hexagon and regular octagon. Got it, children? So, now let us find out the perimeter of an equilateral triangle. Now, consider triangle ABC with side A. That means all the sides are equal, isn't it, children? Because it is equilateral. All the sides are equal. I am assuming the length of the side as A units. So, the perimeter of triangle is sum of the three sides. So, here perimeter of this triangle ABC, which is equilateral, is given by A plus A plus A. So, adding all these three like terms, we get 3A. Hence, I can say that the perimeter of equilateral triangle is 3 into, what is A, children? Length of its side, isn't it, children? So, I can write perimeter of equilateral triangle is 3 into length of its side. Now, let us learn about perimeter of square, children. Now, consider square here whose length is A units here. So, all the sides are equal and equal to A units, and the perimeter of a square is sum of the length of all its four sides. So, here perimeter of a square is A plus A plus A and plus A. So, on adding these you get 4A. That means I can say perimeter of a square is equal to 4 into length of its side. Again, see here 4 is number of sides of a square into length of its side. Now, let us generalize this, children. So, let us see here. We have seen the polygon, that is an equilateral triangle. The perimeter of equilateral triangle is 3 into length of its side. We have already seen that, children, isn't it? Now, what is perimeter of square? 4 into length of its side. Now, can you imagine, children, what will be the perimeter of a regular pentagon? So, you know what is a pentagon? It has 5 sides, and regular pentagon means 5 equal sides. So, what will be its perimeter? Yes, number of sides, that is 5 into length of its side. Now, similarly, can you guess the perimeter of regular hexagon, children? Yes, hexagon has 6 sides. So, 6 into length of its side. This is the formula to find perimeter of a regular hexagon. So, I can say that perimeter of a regular polygon of n sides is given by n into, n is the number of sides into length of its side. So, this is how we can generalize the formula to find perimeter of a regular polygon, children. So, let us take an example, children. A piece of wire is 60 centimeter long. What will be the length of each side if the string is used to form a regular hexagon? So, let us start the solution, children. So, first clearly go through the question and understand what is given to you. So, here a wire is given whose length is 60 centimeters and it is made into which one, children? A regular hexagon. That means 6-sided figure, and that too all the 6 sides are equal, isn't it, children? That means the perimeter of regular hexagon is 60 centimeters, because with this 60 centimeter wire only hexagon is made. So, perimeter of regular hexagon will be 60 centimeters. The number of sides in a regular hexagon is 6. Got it, children? So, let the length of each side, the regular hexagon, be 8 centimeters. Then, what is the formula, children? We have seen perimeter of regular hexagon is 6, because number of sides are 6. So, 6 into length of its side. Let us substitute the values, children. So, we get 60 equal to number of sides 6 into A. Then I write A is equal to 60 divided by 6. So, I can simplify this further, children, right? 6 goes 1 times and in this it goes 10 times. So, what do you get the value of A? Yes, A is equal to 10. That means I can say that the length of the side of a regular hexagon is 10 centimeters. Got it, children? So, children, till now we have learnt about the concept of perimeter, and also we have seen the perimeter of triangle, rectangle, equilateral triangle and some other regular polygons also, isn't it children? Now let us learn about the concept of area. Okay children, let's see. So look at the images shown on your screen children. Yes, these are all plane figures, isn't it children? And all the plane figures are occupying some surface, isn't it children? Now if you place all these plane figures on any flat surface, if it's C children, it will occupy certain region. So we call it as area. Whatever the region it has occupied, that we call it as its area. So the region enclosed by these closed figures is called its area. Now let us learn about area of rectangle now. Now consider the rectangle shown on your screen, and now I am dividing this rectangle into a total number of, see how many squares children? Yes, there are 12 squares. That means since the number of squares are 12, the total area is also equal to 12. So each is 1 square unit. So there are 12 squares. So total area will be 12 square units. But this, if you notice this length of the rectangle, so how many are there? 1, 2, 3 and 4. So it is 4 units. Now take a look at the breadth children here. So how many units children? 1, 2 and 3. So breadth B is equal to 3 units. Now I am going to write this area of rectangle 12 as 4 into 3, which is nothing but length into breadth, because 12 can be written as 4 into 3, isn't it children? Now take a look at another rectangle children now. Now this consists of how many unit squares children? Yes, 15 are there. That means the length is 5 units here, whereas the breadth is 3 units. So the area will be how much children? 15. Now this 15 I am writing it as 5 into 3. Again 5 is the length and 3 is the breadth. So from this we can conclude that area of a rectangle is length into breadth. Now you take any rectangle, you will always notice that area of a rectangle is length into its breadth. So this is the formula to find area of a rectangle. So let us take an example children here. Find the area of rectangle whose length and breadth are 15 centimeters and 11 centimeters respectively. Let us see the solution. So here length of rectangle is given as 15 centimeters and breadth is 11 centimeters. So area of rectangle is L into B. Now just substituting the values of L and B, that is 15 into 11. On multiplying we get 165. Therefore I can write the area of the given rectangle is 165 square centimeters. Now let us see about area of square. Now consider a square here children. Now this square, again I am dividing it into some unit squares. You can see how many are there? Yes, there are 9 unit squares. So the area of the square is 9 square units. And if you notice the side, that is length of the side, it is 3 units, isn't it children? And even here also it is 3. That means all the sides will be 3 only. That's why it is called a square, because all sides are equal. Now this 9 I can write it as 3 into 3. That means area of a square, can I write it as side into side? Let's see whether it is correct or not by taking another example also children. Now I will take a square. How many squares are there? 16 unit squares. So the area is 16 and the length of the sides is 4. Therefore 16 can be written as 4 into 4. That means again area of a square is, I can write side into side. Now this is the formula to find area of a square. So let us take an example children. If the area of a square is 169 square centimeters, find the length of its side. Let us see the solution. So here a square is given to us and its area is given 169 and we don't know the length of its side. So I am assuming it as S. Got it children? And we have seen already area of a square is side into side or S into S square units. So 169 is equal to S into S. Now I can write 169 as 13 into 13 because 13 13s is 169. Since we have S into S, I am writing it as product of 2 equal numbers. So I can write S is equal to 13. That means the length of the given square is, the length of the side of given square is 13 centimeters. So let us see about area of parallelogram children now. So here is a parallelogram. So this is the base of a parallelogram and we have height of the parallelogram. Now I will cut along this height children and I will just move towards its right. Now what is formed children here? Yes, a rectangle is formed. Now here this base has become the length of the rectangle whereas the height has become its breadth of the rectangle. Now can I say area of parallelogram is nothing but area of rectangle? Yes, we have converted the parallelogram into a rectangle. We know that area of rectangle is length into breadth, so area of parallelogram will also be length into breadth. But here what is the length? Nothing but base, and breadth is nothing but the height. So I can write it as base into height. Hence area of parallelogram is given by base into height. So let us take an example, children. Find the area of the parallelogram with base 10 meters and height 5.6 meters. So let us write down what is given to us. Base is 10 meters and height is 5.6 meters. Now area of parallelogram is base into height, or simply b into h also you can write, children. So substituting the values, base has 10 and height has 5.6, we get 56 on multiplication. That means the area of the given parallelogram is 56 square meters. So children, let us now learn about area of triangle. So consider a parallelogram here, and here you can notice a diagonal, and this diagonal of a parallelogram divides it into two triangles, and these two triangles are congruent. And children, we have already learned that any two congruent figures have same area. That means here also the two triangles have same area. So let us draw the height of the parallelogram, okay, and let base of the parallelogram be b and height be h. Now here area of each triangle, so here we have two equal triangles, isn't it, children? And area of each triangle or one triangle will be half of this parallelogram, isn't it, children? Suppose this is 5 square units and this is 5 square units, total area of the parallelogram will be 10. That means area of triangle will be half of parallelogram, isn't it, children? So half, that means 1 by 2 into area of parallelogram. We have already learned that is base into height. So area of triangle is given by half into base into height, or simply I can write half bh square units. So children, the formula to find area of triangle is half into base into height. Now let us take an example. Find the height of a triangle with area 220 centimeters square and base 40 centimeters. First write down what is given, that is base of the triangle, b is 40 centimeters. And what about the height of the triangle, children? Yes, we don't know, right? We have to find. So I am assuming it as some h centimeters. So area of triangle is half into base into height. Now let us substitute all these values now. So area is 220 equal to half into base is 40 into h. Now this on simplification I get 220 equal to this goes 20 times, right, children? 2 goes in 40 20 times, so 20 into h. So what is the value of h now? 220 divided by 20. Simplify using common factor. So 20 goes in 21 time, and whereas in 220 it goes 11 times. Therefore h is 11 centimeters. So children, let us learn about the area of rhombus now. So consider the rhombus shown on your screen, children. So a rhombus, all the sides are equal, isn't it, children? So here ABCD is a rhombus, and if you notice BD and AC are its diagonals intersecting at O. So here how do we define a rhombus? If all the sides of a parallelogram are equal, we say it is a rhombus. So now in this, the diagonals bisect each other perpendicularly. This is very important property you need to remember, children. That means this point O will become midpoint of AC as well as BD. That means I can say OB equal to OD and OA equal to OC. Apart from that, if you notice AOD angle, angle AOB, angle ABOC, angle COD, all are equal to 90 degrees. So diagonal bisect each other perpendicularly, and I already told you the meaning of bisecting each other. But one more important thing you need to remember is the diagonals won't be same, children, here. Got it? Now let us find out the area of rhombus, children, now. So let us assume that the length of the diagonal AC be D1 and the length of the diagonal BD be D2. Now area of triangle ABD is equal to, so if you consider ABD, this will be base and this will be height, right, children? So half into base into height. So base is BD, height is OA. Similarly, what will be area of triangle CBD, children? So base, again I take it as BD and height will be OC, children. So half into BD into OC. Now area of this rhombus will be equal to, sum of the areas of triangle ABD and CBD. So let us substitute the values, children, here. And substituting this, do you notice anything common in these two terms? Yes, half BD is common. Now take out half BD common, children. What is left? OA plus OC. Now from this figure, what is OA plus OC? OA plus OC is AC. That means I get half BD into AC. But BD is D2 and AC is D1. So I get half into D2 into D1. That means area of rhombus is half into D1 into D2 square units. So this is the formula to find area of a rhombus, children. Now let us learn about the area of trapezium, children. Now let's see what trapezium is. Now take a look at this figure ABCD. It is a trapezium. Now AC is the diagonal. Okay. And if you notice, AB is the length of one of its parallel sides. So AB and CD are parallel sides, and length of AB is A and length of CD is B. Let us draw the distance between the parallel sides, or simply I can say height of trapezium. I will mark it as H. Now extend CD to F and join AF, and it should be a perpendicular one. So the distance between two parallels will always be same, right, children? So if this is H, obviously this will become H. Now let us find out the area of this trapezium ABCD. So area of trapezium ABCD is given by area of triangle ABC plus area of triangle ADC. Now let us substitute the value of area of triangle. That is, we have already learnt area of triangle is half into base into height. So for this area of triangle ABC, base is AB, height is CE. So half into AB into CE plus for this triangle ADC, base I am taking it as CD. So height will be AF. So half into DC into AF. Now let's substitute the values of AB and CD. So AB is A and CD is B, that we have substituted, and CE and AF both are equal to H. Now again, do you notice anything common, children, here? Yes, half is common and H is also common. Now let us take these two terms as common factor. Now if I take half H common, what is left? A plus B. So half H into A plus B. Therefore I can say that area of trapezium is half into H into A plus B square units. Now let us take an example, children. Find the area of trapezium whose lengths of parallel sides are 50 meters and 35 meters, and distance between the parallel sides is 40 meters. Let us start the solution, children. So first write down what is given. So length of parallel sides, A is 50 meters and B is 35 meters. And what is the distance between parallel sides? That is nothing but height of the trapezium. So 40 meters. And we have learnt area of trapezium is half H into A plus B. So let us substitute the values. Half into H is 40 into A is 50 plus 35. Now what do you get, children, on simplifying? So on simplifying this, you get 20 and 50 plus 35 is 85. On multiplying these two, you get 1700 square meters. Hence I can say that the area of the trapezium is 1700 square meters. Now let us learn about area of quadrilateral, children. So quadrilateral is a simple closed figure with four sides, isn't it, children? It is a polygon with four sides. Now this diagonal AC divides it into two triangles. And notice, children, here they are not congruent, just they are simply two triangles. Got it? Now I'll mark the diagonal AC as D, and let us draw a perpendicular from B on diagonal AC. Let the length of this perpendicular, or I can say altitude, as H1. And I'll draw another altitude from D on AC, and I'll mark the length of that altitude as H2. So both are altitudes, H1 and H2 are altitudes from B and D respectively. Now area of quadrilateral ABCD is given by area of triangle ABC plus area of triangle ADC. So let us take this area of quadrilateral ABCD equal to triangle ABC plus area of triangle ADC. Now let us substitute the values of area of triangle. We have already learned this formula, isn't it, children? So area of triangle ABC is here, base is D, I'll take AC, that is nothing but the length as D, and its height is H1. So half into D into H1 plus area of triangle ADC. So again I am taking the base as AC, and what is the length of AC, children? D. So half into base is D into what is the height of this triangle ADC? H2. I am substituting it as H2. Now anything common in this? Yes. Again we notice half into d is common. Now take out that one. Now if I take half d common, you are left with h1 plus h2. So area of quadrilateral is given by half into d into h1 plus h2 square units. So let us take an example, children, here. Find the area of a quadrilateral PQRS whose length of diagonals PR is 10 centimeters and the length of perpendiculars from Q and S on PR are 5 centimeters and 7 centimeters respectively. So children, just go through the question once again clearly and draw the figure here. We have given a quadrilateral PQRS. In this, I am going to draw an altitude from Q and from S, and given this is 5 centimeters in length and this altitude is 7 centimeters in length. So length of the diagonal D is equal to 10 centimeters and H1 is 5 centimeters, H2 is 7 centimeters. And using this formula of area of quadrilateral, we can find its area. Now let us substitute the values, children. So here half into 10 into 5 plus 7, because half into this is D 10 and H1 plus H2 is 5 plus 7, which is 5 plus 7 is 12. So this goes 5 times 5 into 12, you get 60 square centimeters. Therefore, area of quadrilateral PQRS is 60 square centimeters. So children, till now we have learnt the concept of perimeter, area, and also we have seen some formulae to find out the perimeter as well as area of some plane figures. Now with this we have come to the end of our session, children. So we are going to recap what we have learned in our today's session. Got it, children? Let's see. The length of boundary of a closed figure is called its perimeter. Perimeter of a square is 4 into length of its side. The region enclosed by a closed figure is called its area. And area of a rectangle is given by length into breadth square units. Area of a square is equal to side into side square units, or simply you can write it as S into S also, children. And area of a parallelogram is equal to base into height square units, or simply B into H. And area of a rhombus is given by half into D1 into D2 square units, where D1 and D2 are length of diagonals of rhombus. So children, before we conclude, I would like to give you some problems as assignment. So please do the problems and submit to your teacher. So let us look at our first problem, children. The length of a rectangle is 25 centimeters and its area is 325 square centimeters. Find its breadth. The next problem is find the area of a trapezium whose lengths of parallel sides are 25 centimeters and 19 centimeters and distance between the parallel sides is 15 centimeters. Third problem is if the area of a rhombus is 135 square centimeters and one of its diagonals is 18 centimeters, find the length of the other diagonal. And our final question is if the perimeter of a square is 20 centimeters, then find the area of a square. So children, with this we have come to the end of our mathematics digital class. I hope you have learnt all the concepts that are taught to you today. So I want you to once again go through all the formulae and learn perfectly before you start solving your problems. And also children, don't forget to do your assignment and please do submit to your respective teachers. So children, now I'll take leave from you and we'll meet in our next digital class. Until then, goodbye and take care.